In this video, we'll learn about rotations at the time of insertion, that is at the time of creation of AVL tree. When we are creating an AVL tree and inserting any key in an AVL tree, then some nodes may become imbalanced. So tree becomes imbalanced. So to balance that, we perform rotations. So those rotations are named as LL rotation, RR rotation, LR and RL rotations. We'll understand all these rotations one by one. So let us start with the first one. First one, LL rotation. Let us take a initial tree. Suppose this is an initial AVL tree. What are the balance factors? See, this balance factor of this is 0 and this is 1 and 0. So this is 1 minus 0 is 1. So balance factor of this node is 1. Then I want to insert a value 10. So after inserting 10 in this one, so where 10 will come? 10 is less than 30, less than 20. So it will come on this side. So 30, 20 and 10. What are the balance factors? This is 0. This is 1 minus 0. So 1. This is 2 minus 0 on this side. So this is 2. So this node became imbalanced. So the balance factors should not be more than 1. So but the balance factor is 2. So this node became imbalanced. Now we will give the name for the imbalance. When this node became imbalanced because of insertion of 10. So in which direction that 10 is inserted? Left of left. LL. So I will give the name as LL imbalance. So this is LL imbalance. Now for LL imbalance, how to perform rotation? Let us take the tree once again here. So we'll perform rotation around this node. So we'll perform rotation in this direction. This direction. So what does it mean by rotation? Imagine that this is a thread. Okay, keep your finger here and pull the thread on this side. Pull the thread on this side. So if you pull the thread, it will rotate around this finger, right? So when it rotates around this finger, 30 will come on this side and 20 will move up at here and 10 will move little above its position. So the tree looks like this. This is the meaning of rotation. Hold your finger and move this node. So rotate around your finger, rotate around a fixed point. Okay. So this is the rotated tree. Let us check the balance factors. This is 0. This is 0. This is 1 minus 1. 0. All are balanced. So around which node we have rotated? This node. So at that place, who is there now? 20. Is it balanced or not? Yes, it became 20. Yes, its balance factor became 0. So on whichever node you perform rotation, the balance factor should become 0 for that one. Earlier, at that position, the balance factor was 2. Now the same position, the balance factor is 0. So this is the procedure for rotation. Now few important things. First thing, what should be the name of this rotation? Imbalance I explained, LL imbalance, right? So let us call the rotation also LL rotation. So I will give the name as LL rotation. So based on imbalance, I have given the rotation name also as LL. Now you can say that, no, it is rotating on the right hand side. We are pulling it on the right hand side. Call it as right rotation. Okay, that is also correct. Then somebody say that, no, it is rotating like a clock. So it is clockwise rotation. Okay, call it as clockwise rotation. So you can give any name. There is no standard name for this one, right? This is just a rotation. There is no standard name. So if you want, you can give any name. I have selected the name so that it is easy for understanding even the complex things. So I am calling it as LL imbalance. If I call it as right rotation or clockwise rotation, maybe I may not be able to explain you the things more clearly. Let us follow LL rotation. So this is after LL rotation. So this is about name. Now second important thing. You may be thinking that I have taken just a small tree just with the 3 nodes. What I should do if the tree is very big? So don't worry. Rotations are always done with 3 nodes only. Always done with 3 nodes. Even if a tree is having 1000 nodes also, rotation is performed over 3 nodes only. So understand this clearly. Then through examples, I will show you how it is done on bigger size trees also. So that's all about first rotation, right? Now next we will look at RR rotation. For RR rotation, this is the initial tree. Balance factor, leaf node is 0 and this one is 0 minus 1. So this is minus. Next, I will insert 30 in this one. So 10 and 20 are already there. So 30 is greater than 10 and greater than 20. So it comes on this side. Now the balance factor of this one is 0. This is 0 minus 1. So minus 1. This is 0 minus 2. So this is minus 2. Minus 2 is not a valid balance factor. Balance factor cannot be less than minus 1. This is minus 2. So this node became imbalanced. So why it became imbalanced? Because we have inserted 30 just now. Where we have inserted right child of right child. Right? It is the right child of right child. So RR. So let us call this as RR imbalance. Now let us see how to perform rotation. So I'll take a tree once again. Perform rotation around this node in this direction. So it means hold your finger here and pull this 10 on this side. So if you pull 10 on this side, then 10 comes here, 20 will take the place of 10 and 30 will move up little bit. Now the balance factor are, this is 0 and this is also 0. So it's perfectly balanced. Now what should be the name of this rotation? As I said, this is RR imbalance. So let us call this as RR rotation only. So this is RR rotation. So this is after RR rotation. If you say no, this is left rotation, okay, you call it. If you say no, this is counterclockwise rotation, okay, you can call it. You can give any name you like. That's all. Now one important thing. In LL rotation, the final result was this one, previous rotation. And this rotation also same result. Yes, in all 4 rotation with just 3 nodes, we get the same result. That is a balanced tree. Now, next rotation we'll look at, that is LR rotation. For LR rotation, this is the initial tree. Let us insert 20 in this one. So, right now tree is having 30 and 10. 20 is less than 30, so it will come on left side. But it is greater than 10, so it will come on right side. What are the balance factors? This is 0. This is 0 minus 1, so minus 1. This is 1, 2 minus 0. So this is 2. 2 minus 0. This node became imbalanced. This is imbalance. Which direction insertion is done? Just now we inserted 20. On which side? Left, right. So left, right. First left child, then right child. LR imbalance. So let us call this as LR imbalance. And how the rotation should be performed? I will redraw a tree here. So first we'll perform rotation around this node like this. So what will be the result? 30, 20 and 10. Right? Pull 10. Holding a finger here, pull 10. 10 comes this side. 20 moves up. So this is how the tree looks like. The balance factors are 0, 1 and 2. Now perform rotation around this node like this. What is the result? Same old result. So 20 in the root, 10 and 30. See, pull 30 on this side. So 20 will move up, 30 will come down and 10 also will move up. The balance factors are 0, 0, 0. What do you call to this? LR rotation. LR rotation. This is also LR. If you want to give the name based on the direction of rotation, just watch it. Left rotation, then right rotation. So this is LR only. With that respective also it is. So this is LR rotation. See, this is one rotation only. But there are 2 steps in this one. So we call this as double rotation. We call it as double rotation. Later I will talk about this one. This looks little complex how to do this. So I'll show you a direct method for this one. Let us take this tree once again here. So this 30 should move this side, root should move this side, and this newly inserted node should go in the place of root. So 20 will flip on this side, right? It will come on this side. 30 will move towards right. 20 when it went on the root, 30 went on right side. So instead of 2 steps, we can see it as a single step. So you have to send this node there and move that node on right side. So that's all about LR. Then RL, I will explain you quickly. You have understood how these are working. For RL rotation, this is the initial tree, 10 and 30, right? Now we will insert a new element, 20 in this one. So if we insert 20, 20 is greater than 10 but less than 30. So it comes this side. Then the balance factors are 0, 1 and this is -2. So this became imbalance. Which imbalance? Right, left. So RL imbalance. So in short, I wrote RL imbalance. And one more thing, see, we get that result only. So that's why I did not remove it. We get that result only. Always we are getting same result for 3 nodes. Anyway, we have to perform rotation on this one. So I'll take a tree once again. Balance factors are 0, 1 and -2. Perform rotation over this node first. So 10 and at this place comes 20 and on right side it will be 30. So the balance factors are 0, -1 and -2. Then perform rotation around this node, we get that result. 10 is pulled down, 20 comes here, 30 also moves up. We get that tree. If you want to see a direct method, then this should be sent as a root or a parent and this should move on left side. So again, this is also double rotation, right? Because there are 2 steps. Actually, these are the steps, but for understanding, we take that one. So whichever you are comfortable with, you can follow that one. That's all about 4 rotations we saw. Let me write down the rotations we have seen. First is LL rotation. See, LL or RR rotation, these are called as single rotations. These were having single step. And LR and RL are called as double rotation. But don't count this as 2 rotations. Count as 1 only. See, there is a difference between double and 2. So don't count them as 2 rotation. This rotation, if I take LR, it is 1 rotation. But it is having 2 steps, so it is double. Capacity is double, size is double, number of steps are double. Person is 1 only, but his size is double. So that's all about rotations. Now out of 4 rotations, I'll give you one observation that may be very useful for you. That may be logically useful for you. Observe this one. So out of 4 rotations, what is the observation? Look at here. So using 3 keys or 3 nodes, so I have 3 nodes, that is 3 keys. Using 3 keys, how many different binary search trees we can form? 5. How? 2n cn by n plus 1 number of binary search trees we can create out of n keys. So for 5 trees we can create. So what are those? How they look like? I will draw them. See, these are the 5 trees. Out of 3 keys we can generate 5 different binary search trees. 2n cn by n plus 1. 5 are possible. What is the height? 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1. Oh, that is of minimum height. So 4 trees of larger height and that is of smaller height. AVL trees means height balance binary search tree. So which is more height balance? So when you have 3 keys, you can draw a binary search tree of any shape. All are binary search trees only. So if you have this one, why don't you take that one? Change this one to that one. How to change? We are saying that we are performing rotation. We are saying that we are performing rotation over this one, or double rotation, right? First on this one, next on this one, or double rotation, first on this one, then on this one. So actually we have transformed these 4 trees into that tree because that is height balance. And how we transform? We are saying that we have performed rotation. So this is the idea behind AVL trees. So idea originates from here. When you can have 5 different shapes, why don't you select that shape? Even if you got this one, modify it. Even if you got this one, modify it to that shape. So this is all about rotations at the time of creation, at the time of insertion. Next we will see the examples. If a tree is bigger, how rotation is performed. I'll discuss various things in that topic.